Now let's compile this code. So now the compilation is done and you know it is legit. Now let's try and understand this code. Even if you don't know the language C++ for coding, it doesn't matter. If you know English, that's enough. Now before asking the Arduino IC to perform functions, we should state which components exist in this code, right? So for that, we say include servo.h, which is in the first line. Now, what is this .h? It's called a library. Now, imagine you're going to an ice cream shop to buy chocolate flavored ice cream, but the shopkeeper doesn't know what chocolate flavor is. No, wait. Let's take it for an example. But what if you tell him what the chocolate flavored ice cream is, how to make it, how to make the ingredients are, and all of that? Then he may give it to you, right? Same thing we are doing here. This .h says the component is included with the library servo. Now every component you include should have a library, obviously, while coding, so that whatever internal codes for understanding what a servo is explained in the library itself. So every time you add a library, you need not code several thousands of lines to make it understand what server.h is. Now server.h is given here, same for afmotor.h. Now let's understand how to add this library. Now if you have Arduino 2.2, it is very easy to go to the library manager, or else what you have to do if you don't have 2.0 is go to sketch and you have to go to include library and then manage libraries and then open that and then type whatever library you want to. Now let's search for AF motor. And you should type it with capitals. Now look at this. Now if we have this library installed, then this should perfectly work. I already have it installed, but I have it installed with a different version. It really doesn't matter because you are using Arduino 2.0, so you should install it with the latest version. Now say you should do the same for the server.h. Now after that is done, let's define. Now what is defining a value? When you define a value, you usually define it with a variable. What is a variable? It can be letters, it could be numbers also. For example, hashtag define A0. Now A0 is the place where we are fitting in the pin of the echo pin of the ultrasonic sensor. Same for the A1 of the trigger pin. Now let's define a motor pin. Now for example, now let's just skip a lines to understand what this line is. Now servo. A servo has a VCC, ground and a signal pin, right? Now where is this signal pin placed? Now this signal pin placed placed in the 10th pin of the Arduino header. But while connecting, you can just place the header. That is because the header pin is connected to few pins of the Arduino which are directly giving the signals to the header. Now let's try to understand define speed. Now define speed is very easy to understand. It's basically the speed limit of the motors. For example, it's just a random unit, honestly. It's not centimeters or meters per second or anything like that. It's just a random unit. That's how Arduino's coding works actually, sometimes. Now hashtag defines point 103. Now what is point? Let's try to understand the servo. Now when you are setting up the servo while powering it up, it may move left or right randomly and then stay at a particular position. That's because of this point. This point 103 says that at 103 degrees is the middle point of the servo. For example, if the servo wants to move to the rotate to the left or the right, it has to have a middle point, right? So that it turns halfway left and halfway right to maintain a balance in the angles. So the midpoint is this 103. Now char value. What is char value? Let's skip a few lines again. and try to understand what char value is. Now after serial.available.read, after .read and all of that, what is this? Now this basically says that if the Bluetooth module is available for reading, and that is taken as serial.available, to check whether the Bluetooth module is available. Now serial.read. Now what is serial.read? It basically says if the Bluetooth module is available, it should read what values it is giving. Now serial.print value. Now after reading the value, whatever value, for example the asterisk or the hashtag right here, it will print the hashtag into the Arduino's IC so that it can do the following functions which we will try to understand later. But now the most important thing is, why is this char value defined over here? Now once you get the value, it should make the robot perform certain functions, right? Now so that the robot performs its functions, the char value is defined here. It basically makes the robot understand what function it is and makes the robot do it. Now int left or int right, it's basically saying, now let's skip a few lines. Now you see over here L is equal to left C. This is related to the servo motor. Now left C is to tell the motor to rotate left to check whether there is some amount of distance present in the environment or not. For example, the ultrasonic sensor is sensing this distance when you call the function left, because there may be a distance, there may be an object on the left or the right when you are turning, and our tank does not turn left or right if there is an object. That's why the integer left or right has been defined. Now let's try to understand what int L equal to 0 means. For example, when the ultrasonic sensor is sensing some distance, it should sense from the distance with the calculation with the variable equal to 0. Now if you add the variable, for example equal to say 9, and the ultrasonic sensor gets some distance, for example say 14 centimeters, yes, the ultrasonic sensor distance has some value, has a unit, centimeters. Now for example, if you say L equal to 9, then 9 will be added to that 14, and the final result will be the decision maker. So 9 plus 14, it is 23. So 23 centimeters will be the distance taken by the ultrasonic sensor, and it's according to that distance it will determine whether what action has to be done. Same for the int R. Now servo, basically this defines the servo exists. Now AF underscore motor, DC motor M1, M2, M3. I showed you how to install a library using AF motor, right? Basically this defines a DC motor, and it defines which port or which pin it is in M1, M2, M3 and M4, which is available in the L29 3D motor driver. Now void setup. Now all of the components we have defined and told what functions they do. Serial dot begin 9600. This basically says the Bluetooth module has to start interacting with the app at the baud rate of 9600. Now why 9600? That is the general baud rate which is used in Arduino softwares and the general robotics coding stuff to make the baud rate, to make the communications work. Now pin mode trig output and pin mode echo out input. Now basically we have seen earlier that the trig is the one which emits the waves and the echo is the one which receives the waves, right? So we should make the trig output and the echo input, so that it starts the process of understanding and the distance measurement. Servo dot attach motor, it's basically stating the motor pin, as we have seen earlier, motor pin 10, and is telling that the signal should start right now. M1 dot set speed. Now we have defined the speed earlier as 170, right? Now we are setting the speed right here and calling the function speed. Instead of writing 170 for everything, we're just setting the function speed right here, which was defined earlier. Now void loop. This is where the main code starts. This is where we tell the IC to do certain functions, and those certain functions are the main functions of our code. Now let's start. If serial dot available, as I've explained before, that serial, when we are connecting to the Bluetooth module, it should read the value, right? So now we should search the Bluetooth module whether it is available or around the atmosphere or not. Now once it has identified that, it should read the value. It should try and understand what value we are giving through the app. Now let's take a look at serial dot print and value. Now after the value has been printed, the value, for example, if it is this, then the function forward has to be performed, and that will be performed by using the function char value, as we explained before. Now let's see what forward is. It could be any function, right? Now let's scroll down and see what forward is and what it does. Now M3 and M4, if you have seen our tutorial, is where I connect the motors which drive the tank, and the other two motors are the motors which move the turret and fire the bullets. Now those motors have been set to release. Now what is release? It basically means the motor has nothing to do and no voltage will be given to those two motors release. Now M3 dot run and M4 dot run are forward, and they run forward with the speed of 170 as defined up here. Now same logic has to be used for backward, fire, let and ret. These let and ret are words I created on my own, so that, for example, let is left turret, so the turret will move to anti-clockwise, right? Yes, anti-clockwise. And ret is the right turret, which means clockwise. And all of these functions will only work if the value, exclamation mark, hashtag, or at the rate, or this left thing will be read. Now let's look at what if the ret function has been called, the left function. Now after the left has been called, the ultrasonic sensor will turn towards the left using the servo motor to see whether there is a distance. Now the ultrasonic sensor, it will turn right and left, right, to check whether there is a distance, and if there is a distance less than 10, then the tank will not move, right? So that is basically what is being done here. Now let's look at what left C function is. Now left C is where the servo moves 180 degrees. That's why servo dot right 180 degrees and delay of 800 microseconds, and it turns right to check to get to this point or the middle point. Now after left C has been done, it will check whether the distance forward and towards the left is greater or not. And if the distance is greater than 10 centimeters, then the tank will automatically move to the left. And now after the left function has been called, there's been a delay function being called. For example, there should be a delay every time a function has been called, right? You cannot immediately move around stuff, you cannot immediately run forward and immediately run backward. You have to stop because there is inertia acting on you, right? Now, since for example, using that logic, the delay function has been called so that it can stop. Now after the delay function has been called, the motor stop. Even if you have a function of stop, you still have to add a delay. If the distance is less than 10, then it should stop, because if there's an object less than 10 centimeters towards the left, then the tank should not move, right? Because that is how the tank works. Now you can add the same logic for the right C and to check whether the right function has been called. Else if asterisk, which is stop, which is a different function. Now let's look into the ultrasonic sensors logic. Now digital right, trig low. Now what does that mean? Now the ultrasonic sensor, the trigger should start with a low, because the ultrasonic sensor expects that it starts with a low and then after some delay it goes to a high state. This low is a state for the trigger pin and the echo pin. So now the ultrasonic sensor expects a low state every time before it's being called to function. Now after low, there should be a minimum of 2 microseconds before it is being called to a high state. And I have added a 4 just so that it gets enough time to fix for extra changes, so that it can preset everything and be ready to go. After 4 microseconds, it's being set to high, where the waves are being emitted. Now after the waves have been emitted, it gets a delay of 10 microseconds, so that there's been enough time to get the delay waves emitted and the receiving waves into the echo pin. Now after that, the trig becomes low and then the whole loop works again. Long t equal to pulse in echo high, long centimeter equal to t by 29 by 2. What on earth is this? Also return centimeter. So let's understand this first. The ultrasonic sensor, it emits waves to the trig and then it comes back, right? Now this wave is called as a one wave itself. For example, when it emits from the trig and the object it hits and the waves fall back into the receiver, the ultrasonic sensor, this is called one wave, and the distance is twice, because we are transmitting and it is receiving the wave, so the distance it is covering is twice of the original distance. So that is why this by 2 is given here. Now long t equal to pulse in. What does that mean? The amount of hertz it is emitting and the time it is calculated in the sensor's IC. So basically let's understand some physics. Now sound, in air as a refractive medium, it travels 343 meters per second. Now in the ultrasonic sensor, 29 microseconds, it's calculated and it's found that it travels a distance of 1 centimeter in 29 microseconds. Now this long t equal to pulse in basically understands how much waves, how much hertz, how many hertz it's emitted, and for how much time the ultrasonic sensor has been turned on, which is 10 microseconds, for example, we have given over here. Now after getting all of the data, whatever time it has been emitting for, it will divide it by 29, because 29 microseconds is equal to 1 centimeter, right? And we need the centimeters. We should not calculate the time, we should calculate the centimeters. Now after the calculation has been done, return centimeter is the final amount of centimeters, or the object distance that has been calculated. Now this by 2, let's understand what this by 2 is. I told you before, right? I told you before that the trig pin emits the waves, and then after it hits the object, the waves come back, right? Now this whole process is one wave. Now this one wave is twice the distance, right? So we should divide it by 2 to convert that into the actual world distance. And that is the logic of the ultrasonic sensor explained. Now I have told you the functions, right? Void forward, void backward. Now why void? Because it is a separate function itself. So void forward, what it does is it makes the tank's actual motors drive the tank for M3 and M4 as connected in my tutorial. And M2 and M1 have been released because when you are driving the motors, the tank should not fire and the turret should not move, right? So that's what. Void backward, the same M1 and M2 have been released, and the M3 and M4 have been called backward. Now void right. Now the same M1 and M2 have been called released, and M3 is forward but M4 is backward. Why? So now few are moving in a straight line. Imagine a car which is moving forward. Now for example, this tank, it's not a car, right? So the front wheels do not steer. So what we are doing is the tank basically rotates in its axis itself, right? So the left motor moves forward while the right motor moves backward, so that it moves right? So that is being done. So you can play the same logic for left, only that the right motor is moving forward and the left motor is moving backward. Now let's look into let. Now let is left turret, right? And left turret is anti-clockwise. Now M3 and M4 have been called release because we are calling let when the tank is stationary. So when the tank is stationary, only then can you fire and aim properly, right? So the let function has been called with the M3 and M4 to be released, and the M2 will run forward while the M1 is released, because we are not calling the function fire yet. Now rit is the same logic but with M2 as backward because clockwise. Now void fire. Almost everything has been called released except for M1, which is connected to the firing motor, which is firing the rubber bullet. And this is called motor function is called forward. It is called forward because the thread of the actual nail which is connected to the motor, if you have seen in my tutorial, it is moving forward so that the rubber band which is attached to the thread moves upward, and then when the tension is released between the rubber band and the ice cream stick small piece, it will move forward because of the potential energy the rubber band has. Now why forward, why not backward? Now you have to test this on your own when you are making the project. Now I have chosen forward because the motor, when it is moving in the forward direction, I don't remember, but whether in anti-clockwise or clockwise direction, when it's moving anti-clockwise, for example, say that it is moving anti-clockwise direction, the rubber band moves upwards. But when you are moving it in clockwise, then the rubber band will move downwards, which is what we do not want. That's why the motor function forward has been called, not backward. Now stop is very easy. You ask everything for it to be released. And right C and left C, we have already explained it before. And that's what codes basically are. And thank you so much for watching until the end.